Thanks, Hannah. So I'm really excited to be here at our first Neo4j I. Last year in May, we launched Neo4j Graph Analytics for Snowflake. And I'm really excited. We've got a Neo4j agent. It's been in preview for a few months now. And I'm hoping that we'll have that by GA for this time next month. Tim and I are going to take you on a ghost busting tour. He's out in New York and the New Jersey area as our senior ghost solutions engineer, collecting all the data in the dangerous line of fire, like fighting ghosts. I'm here in London, our data HQ. I'm the lead data product manager. I'll be doing the ghost analytics for you today. I'm just going to hand over to Tim now, who's going to kind of set the scene and explain everything he's doing in Snowflake. Over to you, Tim.
Thank you. Yes, I got a couple extra slides there just for when people get the slides later. But what I want to really show you is how easy it is to work with any data. It's not scary anymore, no matter what it is. You may not understand your data, but with the combination of the right tools and the right people and technology working together, you could solve any problems. And with Snowflake and Neo4j and Cortex Code and AI and MCP, we can get down to everything we need to do. First thing I want to show you real quick is how we could collaborate across continents and time zones and, astral realms here. So first thing we do is take advantage of the close partnership between Neo4j and Snowflake, and I am sharing my ghostly data that I'm capturing here in New York and Princeton, and I have a private share from Virginia going all the way over to Neo4j so that we can work on the same data. So Stu can do the analytics on the data as soon as I capture it. So over here in the United States, I've used Cortex Code to build up a couple of quick applications so that I can get the data in. Some of it we acquire through public channels. Some of it is us in the field, whether I'm here in North Jersey or over in Manhattan, where there's lots of different things going on. Some of that reported by the public, some in social media, how have you there. I've got a couple different ways of looking at this data and capturing it, because with the power of Cortex Code, I could just build these up almost instantly. In fact, for this one here, I saw Josh Long say good luck on our session, and I'm like, hey, we should have a Spring interface to add new data. So yesterday I took 20 minutes and had Cortex Code build a Spring Boot app just for you, Josh, so that we could do this and bring in data when it comes in really quickly, process it with Cortex to get the basics in there, use agents to make sure our data looks good before I hand it over to Stu. So we only have the latest and greatest data. So Stu, going over to you in London.
Cheers, mate. If you could stop sharing, then I'll. Cool. That'd be great.
You got it.
Excellent. So as Tim explained, he sent us a data product. So I've requested that. He's approved it. I received that request via email. So jumped into my dashboard. And what I'm going to do is just take you through how I've got a setup here inside of Snowflake. So Tim's got the ghost data that he shared with me. I've got kind of ghost information, the ghost sightings. I can see a preview here. Now, because in my analysis I'm going to need to write data, I've had to create a view of Tim's data. So if we scroll here, I've got my ghost detection, and I've got the very same tables shared as views here. So I can see the same information. So what am I going to use to perform the analysis? Well, as I mentioned at the beginning, Neo4j built a native application for Snowflake. We've been in the marketplace since last May. It comes with a 30-day trial, so please, after nodes, jump in, have a go, there's lots of great content provided in the app listing for you to find out and get going. So to do this analysis, I'm going to create an agent. We've got this psychokinetic energy meter, PKE, agent that I'm going to create. So to do that, I just need to specify the name of the agent, the schema that provides the data, so that's ghost detection.data, and then I can only read from that schema. To write the results, I've got a separate schema, so you keep your data that Tim's provided separate from the data done in the analysis. That's just going to create the agent. If we come over inside of Snowsight, you can see that there's an agents menu. It gives you a list of all the agents. You can basically have an agent per data set. So an agent specializes on the data. So I've got one that analyzes open flight data. That's another great demo. So if I hit refresh now, I should see my PKE meter agent. So we're locked and ready to go. I've got a prompt. It's a bit more elaborate than you would probably need. I just want to make sure that the Snowflake intelligence and the agent do the right thing in the shortest amount of time. And at the moment, the agent would try and use threat level and verified, which are varchar that we need to process only numeric data. So I'm going to submit my prompt. And the great thing about the agent is it provides a tool that explores your data, figures out what are the nodes and what are the relationships. So you don't need to do that. It makes it super simple to do some exploration. So it's inspecting. I'll just expand here. You can see it's identified what's in the database. It's going to propose some views that it can create. So the views of nodes, string properties, so it can make sense of, or I can make sense of the information at the end, and then the relationships view. Okay, so we're now ready to do some analysis. Now, Tim and I have been talking about the problems he's facing in the field, and he's confronted with all these ghosts, and he needs to kind of really focus. So we suspect that some of the ghosts are acting as gatekeepers, right? Find the top, I can't type, top 5, which basically means that he can now get going and focus on specific sightings. I'm just going to wait. It needs to update the semantic view. So all the tables of views that it creates, it records in the semantic view, so it knows how to combine results with other queries, which becomes really helpful in later analysis. So we're all ready to go. It gives you a nice summary of the graph structure. This, again, if you're new to graph, is super helpful. You don't really have to figure stuff out. Obviously, if you know graph and you know really well, then knock yourself out. You can specify your own. So let's see what it's going to do. Now, I haven't specified the algorithm that I want to use. If you don't know, you just describe the business problem, right? What's the business problem? Well, in this case, it's not really a business problem. We're being overrun by some ghosts, right? And it's picked up from gatekeepers that really it needs to use between us as an algorithm. So what's betweenness about? So if we think about ghosts, basically betweenness is looking for influence, like which ghosts are creating the most influence over the whole network. They essentially act as a bridge and a communication point between all of them. So you measure the shortest path between pairs of ghosts, and then the ghost with the most shortest paths that pass between it has the highest betweenness figure. So this is super useful for analyzing communication networks, helpful for transport networks, spotting disruption that can occur when ports are out of action, maybe a warehouse fire and how that can impact. If you're in the pharmaceutical industry, then how proteins work and influence on the body system. If you're looking at communication networks, then maybe like your routers and stuff, which ones are prone to bringing down entire parts of a network. So a range of kind of analysis problems beyond just ghosts. So let's cut back, and hopefully we've run the analysis. It's figured out the configuration. Let me just expand what it's thought about. It can get the algorithm config, generate that configuration, but I think one of the things that's kind of helpful is it knows what it's doing here, and it's figured out the configuration. So if you're new to our Graph Analytics application, you haven't learned the syntax. It's predominantly kind of like a JSON-based format for passing into the SQL procedure that describes the nodes, the relationships, and the algorithm that you want to run. But you don't have to learn that. Get going. Super fast analysis. So hopefully it will finish in the next few minutes. And please post any questions. Hopefully Tim and I will have time at the end to be able to answer those questions, especially while some thinking is going on. So please knock yourself out. And I am hopeful that it's going to get there pretty soon. Whilst it's doing that, let me just talk about what we're going to do next, right? So the next problem, right? You know, there's loads of ghosts all over the place, but really it'd be kind of helpful if we could categorize them. If we've categorized them, we kind of know what Tim and his team are going to be facing in the field. So that's going to be the next prompt. Again, I haven't specified any algorithm. I'm just telling it like what the problem is that we want to solve. So bingo, excellent. It's come back. It's told me how many ghosts there are, the locations, and it will just come back. So to give me something that I can understand instead of just like a bunch of numbers, it's going to combine the results with one of the other views it created, which had all the string properties, which then means that it can give me some really helpful, hey, the ghost name colonial spectra, apparition 1, its threat level, how often it appears, and its confidence score, and it's got this super high betweenness score. You generally only see something this high in ghost data. You probably wouldn't see it in many other types of data sets. So we're all good there. So I just forgotten the prompt. Oh yeah, that's it. So lots of information on ghosts. Encode it for me so we can categorize the ghosts into 5 types. I think that seems pretty reasonable. So Snowflake Intelligence is off analyzing my request, and it's figured out that there's 2 embedding algorithms. So when I said encode, FastRP and node to vec. Now, FastRP or fast random production is a super fast way of analyzing really high large graphs, like up to 1 billion kind of nodes. So we're talking like a lot of ghosts. It'll probably pick fast RP. I did say kind of quickly. And then it's figured out that k-means is a good way of clustering. So whilst it's off doing that, I'm just going to talk a bit about like how fast RP works. So as I said, it's a way of encoding information in our ghostly network. It's super fast. Every ghost starts with kind of like an aura. It's a random aura. And then because we said k equals 5, we would typically have 5 centers. In this graphic, I've simplified it to just 3. So it picks 3 ghosts that act as the center of these clusters. Then it kind of loops around all the ghosts, comparing the auras, assigning them the ones that are closest. It joins that ghost, and then it kind of iterates round until such point that the network is stabilized and you've got a vector that represents the ghost in the ghostly network in space. Now we've got the vector. What do we do with it? Well, machines and machine learning love numbers. That's really the only thing they understand. So these vectors are a great way of basically comparing the vectors using cosine similarity to figure out the closeness. So you start off, all the ghosts have got their vector. You pick 3 as a center, and then you kind of iterate around joining those clusters. A ghost can only be in a single cluster, and you basically repeat whilst ghosts figure out which cluster they belong to based on those vectors. And then once things are stabilized, you've got your categorization. Basically, this is a form of unsupervised machine learning because our ghosts didn't have a category, and we hadn't come up with any beforehand. So it's kind of figured out how these ghosts kind of all relate to each other. So fingers crossed, hopefully we can now come back and check on how Snowflake Intelligence is running. It's still running fast RP. It had to figure out for 32 seconds what it needed to do in terms of the configuration. It did hit an issue in terms of the data. It's basically done that, and we've now got our ghost embeddings. It created 64-dimensional vectors capturing the whole network structure, and now it's going to now cluster those into 5 clusters using k-means, and we are doing pretty well for time. So I have my fingers crossed that in the next few minutes we will have got the results. Whilst it's just running k-means and figuring out, one of the things that Snowflake has got in preview is these artifacts. So earlier today, like when I was testing this all out, it generated some nice graphics dashboards summarizing the results. So you can kind of share them, save them, share them. I could save them over and share them to Tim. Let's just go back, oh, not new tab. I want to go back to how it's getting on. It's still running. One of the other things that's helpful as a prompt, if you're new to the product, what problems can I solve with graph algorithms? Oh, I haven't typed that. I'm sure I'll figure out what I meant there. One of the tools, obviously, our tools know what algorithms we've got in the product, and it kind of comes back and it can kind of summarize the different types. So we've got community detection and clustering, path finding and routing, you know, finding shortest paths for logistics and delivery routes. So again, if you're new to Graph and you want some inspiration about the kind of problems that you can solve, then that's a great prompt for you to use. So let's just cut back and see how it's getting on. It's now thought for a second. Ghost embedding is created, creating the views. It's still executing the tool. If we got any questions that we could maybe take while it's just finishing off its last little bit of thinking?
Yeah, you got a couple of good ones from Vinod down there in the chat for the session.
So yes, any resource on algorithms that are available. Yeah, besides the documentation, I think that prompt that I just showed is the best way. It will tell you exactly what algorithms are there, what business problems they can solve. I think that, can I call this into my agent as an MCP instead of finding it on the marketplace? So what is that? Into my agent as MCP instead of finding it. So the app itself is only available on the marketplace, so you'd have to install that. You don't have to use our agent, your own agent. If it has access to the Snowflake data that it's created, you can query that yourself. So yes. Does this container allow us to build a graph visualization based on the graph model instead of the yes, so we have the Neo4j Python visualization library. It's great. It's basically the same library that's used by Bloom and Browser. So you just do pip install, and you can create some nice styled graph visualizations. You just need to be aware that when you're visualizing the kind of very large graphs created here, you can only really show like about 4 to 10,000 nodes realistically. You don't want to try and visualize a graph of a billion nodes. So you need to kind of create views of the data that the visualization can handle, but you can build Streamlit applications using that. How do we edit the graph given Snowflake is editable? Where does this get that stored in Snowflake? Yeah, so the way the product works is you pass in some configuration. It's a configuration that specifies the view that provides the nodes and the view that provides the relationships. It takes that, projects it into the Snowpark container, into its memory, runs the algorithm, and then writes the result back to Snowflake tables. That means that you can control the information that you pass into the graph by just specifying a view, changing the view. You will change the amount of data that's in there and present it to build the graph. Keep the question coming. Yes, please do. I use Cortex CLI already in my agent to pull the schemas, but looking to integrate Neo4j into my agent to build the context layer. Yep, great. It'd be cool to see Snowflake Streamlit and use this very cool, love the ghosts. Thanks. Yes, I didn't have time to pull together a nice Streamlit app. Yeah, you might say that's actually a bit lazy considering how quick Tim was saying it is to build one. Yeah, I've been making sure that we got a nice, reliable run through with our agent whilst it's in preview. Yeah, we've got a few minutes left. Yeah, as I say, it looks like it has correctly categorized the ghosts into 5 types, identifying kind of the largest group and the smallest group. And as I said, it updates the semantic view with that information, and it's giving me a nice summary. And those summary tiles, I can save them. They'll appear as artifacts, as I showed there. The other really cool and handy thing, you're probably not going to use this in a kind of production pipeline, right? This is a really good way of exploring data, or if you want to democratize data within your organization. But if you want to build a pipeline and run things regularly, then all you can do is just copy the configuration that we provided there, paste it into your notebook, and away you go. So here you can see kind of, we specify the instance size. We've got an estimate procedure that if you pass in the tables for the nodes and relationships, it will kind of try and give you a good estimate for the size of the instance you need. And then we specify the table prefix, so ghost.results for where I'm writing the results, the node tables, the relationship tables, and it's given me it for k-means as well. So that is the end of what I'm glad to say is a successful demo. If we got time probably for a couple more questions. Yeah, Tim, big thanks to Tim for the inspiration. Hopefully I'll earn a badge, a proper Ghostbusters badge to go with my boiler suit that I've got. But yeah, it was his data set, and when I saw it, came across it, I thought, oh, that's so cool. Oh, is that going to be in the post? Excellent. Cheers, Tim. Nice one. Excellent. Yeah, best costume winners. Yes, absolutely. If you know anything about me at Neo4j, I do love getting dressed up. So thanks for all the great questions. Tim, any kind of closing comments from you?
Yeah, thanks for showing off the artifacts. Those are pretty cool new feature in Snowflake Intelligence. You could save charts and graphs. It's a pretty nice thing. We could actually share them too. Maybe next year we'll have shareable artifacts and a Cortex code skill that builds up Neo4j agents and MCP between them, and then, actually be able to send messages right to Ghost to have them do agentic AI for us. We'll see. We're working on that.
Awesome. Yeah, just one last thing. So Olga, she was pretty instrumental in creating the agent. Her and I just published a blog. It's Neo4j Graph Machine Learning. So how to detect network intrusion in an IoT network using all your data in Snowflake. We use KNN, and the really cool thing is because we've got a Python runtime, we're able to run GraphSage on a GPU, and we get fantastic results for predicting network intrusion. So please check out the blog. And as I say, you've all got the opportunity to use a 30-day trial, whether you install it in your company business account, if you're able to do that. Snowflake provide trial accounts where you get a certain amount of credits. You can install our native app in there and use your credits for our native app as well. So knock yourselves out. Hope you enjoy the rest of Nodes AI. I can now sit back and enjoy the remaining sessions. So thanks again for all your great questions. Yeah, Vincent, we definitely need a collab on Ghost Neo4j t-shirts. Yes.